Hello learners, this is Education Online program. I'm teacher Lily. I'm going to teach chemistry, and the topic today is chemical equations and the mole ratios. And here this topic is for senior 3 and 4. So what is this chemical equations? And if you are saying chemical equation, it means there is a chemical reaction that has taken place. It means that there are substances or particles that are reacting together to give you a product or new substance being formed. So this is known as the chemical reactions. So the chemical reaction here can be represented by a chemical equations. So chemical equations goes together with the chemical reaction. If there is no chemical reaction, we should not have a chemical equations. So what is this chemical equation? So chemical equation is the representation of a chemical reaction. So the first thing to put into your mind is to know that a chemical equation is the representation of a chemical reaction. It means there is an experiment that has taken place and we are representing the reaction through a chemical equations. So here we say that a chemical equation is the representation of a chemical reaction. So what is this a chemical reaction? So learners, we need to know that a chemical reaction represents the change in one or more substance act alone or on each other. It means that there is one substance or more substances acting on each other. So it means you can have the same atom reacting with itself to give you a new substance or new atoms being formed. So in this case also you can have more substances or more atoms, different atoms reacting together to give you the new product. So always we need to know that the substance which change are called the reactants. So the substances which change are called the reactants. So here we need to know that here we are representing the substances. Either can be the same atom or different atoms reacting together, and this we call them as reactants. In this case we represent them as reactants. So here reactants here are substances that are reacting on each other or coming together to form a new compound. So we shall say that the substance or substance which are formed are called products. So we need to see that there is also a new term here known as the product. So here the product is representing the substances which are formed after the reaction of one or two atoms or more substances together to form the new substance, and this new substance we call it as the product. The reacting substance are known as the reactants. So in this case we can have atoms of the same substance of the same atom reacting together, or you can have substance of different atoms reacting together to form the new substances. So in this case we call them as products. So you need to remember that in a chemical equation whereby the chemical reaction has taken place, we can represent the chemical equation by reactants and products. A reactant can be one or can be more than one and product also can be one or can be more than one. So we say that a chemical equation can be represented by a reactants and products. So we have known that the reactants and the products, they are different terms. It means that we have the reactants and we have the product in each chemical equation that we are representing. So in this case, we need to remember that in a chemical equation, we have the reactants, or reactants, and also we have the product. So here these are two terms as I've said already, and we are seeing that the reactants in a chemical equation, they are always in the left hand side of the chemical equation, while the product, they are put in the right hand side of the chemical equation. So here we have seen that the reactants, they are always on the left hand side, and the product are on the right hand side of the chemical equation. So we have seen that also these reactions here, they can take place either we can have atoms reacting together. Substances like atoms can react together. We can have ions reacting together, and we can have molecules reacting together to form compounds and more others. So in this case, we shall say that the reactants, they are not always atoms, but they can be ions, they can be molecules reacting together to give us the product. So here the product will have a new compound being formed from either the ions, or can be from the atoms, or can be from the molecules. So in this case, we have seen that the product and the reactant, they are different terms, and they are represented in different places. We have seen that the right hand side is for the product and the left hand side is for the reactants. And the reactants can be either atoms, can be ions, or can be molecules. So we have seen also that here a chemical equation is a convenient means of representing a chemical reaction by using symbols. So we have seen, I've told you that here atoms, ions, or molecules can be the reactants. But how are we representing this? Are we writing them in words? Are we writing them in symbols? Here we are going to see that the chemical reactions are always represented in a chemical equation by either symbols, or by formulas. So here we have seen symbols or formulas. So learners, we know that what are the symbols and what are the formulas when we are talking of chemical reactions. So symbols here are representing the word of an element. So if an element is written in word, it's not representing a chemistry. So in this case, we have to write them in symbols. So each symbol is well known for any scientist or any other chemist who is dealing with the chemical reactions or chemical equations. So we have seen that this can be represented by either symbols or can be represented by formulas. A chemical equation is an expression in symbols. So in this case, we have to remember that a chemical equation is the representation of a chemical reaction. So if a chemical reaction is represented by symbols and formulas, it means a chemical equation do the same. So it means that a chemical equation is also represented by symbols and also represented by formula, as we have seen in this representation of the chemical reactions. So also we have to know that the simplest form in which the reactants and the product can exist are as atoms, molecules, ions, or formula units. So we have to know that the simplest form of the simplest form in which the reactants and the products can exist. So the simplest form in which the reactants and the product can exist are in either atoms, ions, or molecules, and also can be in formula units. So here we are representing the chemical equation by either atoms, by ions, or by molecules, or by formula units. So in this case, we have to remember that the symbols and the formulas are the one working in this case. So if you are asked to write the chemical equation, put into your mind that you are going to use either symbols or you are going to use formulas. So each particle has a name. As I said before, that each particle has a name, whether it is an atom has a name. For example, you can have oxygen. So this is representing an element which is a particle or can be oxygen atom. Here we are saying that it is an atom, or it can be oxygen molecule, or it can be in ions, which is known as oxide ion. So we have representing each particles by either name or can be by symbol or formula to represent it. So the actual or practical measurements of quantity of reactants and products occur in various units. Either can be in mass unit or can be in volume unit. So if you are saying in mass unit, when you are representing the product, so each product or reactants can be represented by either mass, unit, and we usually know that, learners, that the mass unit here is in grams. So it can be in mass unit, which is grams, or can be in volumes here. We can say decimeter cube, or we can say liters, or we can say centimeter cube. These are all representing the unit of volume. So the product or the reactants, they are represented by either mass unit, which is in grams, or volume units, which is in decimeter cube, liters, or you can have centimeter cube. So here we are saying that they can in turn be converted into other units such as moles. So in this case, we are saying that the products or the reactants can be represented by mass unit, or it can be represented by volume unit, and this in turn can be converted into other units. So it can be converted into other units, which is like moles. And here we are saying that we have converted the units into moles. So there are many other conversion of the mass or volume into other units. So here, learners, we have seen that products and the reactants are the most important terms when you are dealing with chemical equations. So here we have also seen that chemical reaction is the most important thing also when you are dealing with the chemical equation. So you cannot derive a chemical equation without getting a chemical reaction. It means in this case an experiment is very important when we are dealing with the chemical equation or chemical reactions. So for example, if the simplest form of an equation is to represent it by names of the reactants and the product, so this is called what equation? So you can also represent the chemical equation in words which may not be very convenient for any scientist, but when we are representing it in symbols or formulas, then it is going to be clear for us to represent the state of that substance, whether it is in solid form, gas form, or in liquid form or aqueous forms. So it is easier for you to represent it in this way. But when we are putting it in words, then it is not very clear. So we are here, for example, we wish to represent a reaction between zinc and dilute sulfuric acid. So if you are given a reaction, we are given a reaction or chemical reaction between zinc and dilute sulfuric acid, then we need to have a chemical equation. So learners, each product or reactants can be represented by mass unit, volume unit, which are, for volume unit we have decimeter cube, we can have liters, and we can have centimeter cube. So for mass unit we can have grams, and these units can be converted into other units such as moles. So if you are given a reaction of zinc with sulfuric acid, we can have the product which are zinc sulfate plus hydrogen gas being evolved. So in this case, if you represent it with the words, then we shall have not clear information about the state of the reacting substances or the products. So in this case, we have to represent it by symbol in order for us to give us a clear information. So you can have an example here, as we are reacting at zinc reacting with what? Reacting with dilute sulfuric acid. We have dilute sulfuric acid. So here we can say that the reaction is represented by zinc in words, zinc plus sulfuric acid. So we have sulfuric acid, then it will give us the product, which is zinc sulfate plus hydrogen gas. So here we have seen that the reactants are zinc and sulfuric acid, and the products are zinc sulfate plus hydrogen gas. So learners, we have seen that here we are representing the chemical equation in words, but actually we have to represent it in symbols. So in chemistry, the standard practice and convenient way is to represent reaction using chemical symbols and chemical formulae. So this is referred to as the chemical equation. So a full chemical equation or a convenient chemical equation is to represent it by words, by symbols and formula, not by words, as you see that I've put here zinc in word plus sulfuric acid in word. Then we shall have zinc sulfate and hydrogen gas. So this one is not a convenient way of writing a chemical equation. So in this case, we have to remember that writing correct chemical equation require some steps. So what are the steps here for writing the correct chemical equation? The first thing is to remember to write the correct names or symbols and formulas of substance involved in the chemical reaction. So learners, here we have to know the steps in writing the chemical equation. So the steps are, one, write correct. You need to write the correct names or symbols or formulae and formulas of the reacting substances. So you need to remember that in a chemical equation, the first thing is to write the correct name or the symbols, which is the convenient way of writing the chemical equation, and the formulas of the reacting substance. So it means there are reacting substances which need to represent them using symbols. So here also we have to show the physical state of each substance involved in the reaction. The second step is to write the physical state. Write the physical state of each substance. Write the physical state of each substance. So learners, here the physical state of each substance are, you can have the physical state as liquid, it can be as gas, or it can be as solid, or in other words, you can have aqueous solutions represented or showing the physical state of the reacting substance. What else is needed when you are writing the chemical equation? So learners, the last thing is the amount of the reactants and the products involved in the reaction. So what are the amounts of the reactants and the products involved in the reaction? So the third thing is, here is to write the amount of the reacting substance. It means you need to know the amount of the reacting substances so that at least you can represent them clearly. Because without knowing the amount of the substance reacting, it means your chemical equation will not be written correctly. So we have the last substance, which is number 3, is to write the amount of the reacting substances. So here the amount of the reacting substance, you need to write them clearly. At least anybody will know that this is the amount of so and so or substance A, and this is the amount of substance B, which give us the product, which is, for example, represented by C, and it has this amount. So you have to write the amount of the reactant and the product involved in the reaction. So the following signs and symbols are used in writing the chemical equation. So also there are signs and symbols for writing the chemical equation. So any chemical equation will have some signs and symbols, which is well known for each person dealing with the chemical equation or chemical reactions. So we have to know that here we can represent S. Here S is representing solid. You can have it for solid. It means that any substance is in solid form, then you have to put S, and usually we represent it by putting it inside a bracket. So in this case we have S is representing solid. So when you have L, here it is representing liquid. And when you have G, it's representing gas. So it means here, these symbols and these letters, they are not just for fun, but they are telling you the state or the physical state of the substances reacting and the product form. If the product was in gas, it means also you need to know the physical state of the reacting substance or the reactants on the left hand side. So also we have to know that there is aqueous, which is represented by AQ. So this is representing aqueous solutions. So this is representing aqueous solution. So whenever you see AQ under the symbol or formula of a chemical reaction, then you remember that this is an aqueous solution reacting, or the product form is in form of aqueous solutions. So you can have a positive sign here, the positive sign on the reactant side, or the positive sign on the left hand side of the chemical equation. So at the reactant side, it shows different meaning. So plus sign, or this sign is representing at the reactant side, it represents different thing, and on the left hand side is on the right hand side or the product side, it represents a different thing. So here on the right hand side, on the reactant side, it means react with. The reactant side, it means reacting with. React with. And the same sign at the product side, it means N. So as I say, these two, this sign, the same sign at each side of the chemical equation are representing different meaning. So as I said, at the reactant side, this same sign is representing reacting with. So it means that you have zinc is reacting with sulfuric acid. So at the product side, the same sign here is representing N. It means the product form. For example, in this example of zinc plus sulfuric acid, so it will give us zinc sulfate plus hydrogen gas. So here it means that the products form are zinc sulfate and hydrogen gas. So you can have the arrow sign. So here the arrow here is representing form or produces. So it represents, it forms, it means that the chemical reaction here forms or produces. It means it is telling you that there is something that has happened at the other side. So note that the symbols are usually placed in parentheses or brackets. So if I say that here, we have to know that the symbols, for example, S, which is for solid, you need to put it inside the bracket. Or you can have liquid, or which is represented by L, is you have to put it in small letters. So it means that you have to put it inside the bracket to represent the physical state of the reacting substances. So hence, whenever we write a chemical equation, we are assuming the law of conservation of mass. So it means from the reactant side and the product side, they should always have the same masses. So here we are assuming the law of conservation of mass. So it means whenever an atom is written, we assume it to be the same atoms reacting to give us the same atoms of the product. So here also we need to learn that learners that it is important to notice that there must be the same number of atoms at the right hand side and the same number of atoms at the product side. We have to know that the same mass of the atom at the right hand side should be the same as the mass of the atoms at the left hand side. So we have to put this one into our mind. It means you cannot have lesser mass at the right hand side and more mass at the left hand side. So it shows that there are atoms being destroyed or being created. So we have to be very keen when you are dealing with these chemical equations. So for example here, as I said before, that we need to represent each substances using symbols. So in this case of zinc, we have zinc is represented by Zn plus sulfuric acid is represented by these atoms, and then we have the product, which is zinc sulfate plus hydrogen gas. So in this case we represent gas by G, and here we have zinc sulfate is represented as an aqueous solution. Also we have sulfuric acid, and we have zinc as in solid. So learners, with this we have known that chemical equation goes together with the chemical reaction, and at the same time we need to remember there is product and there is reactant, and at the same time we have also to know that the same mass of atoms reacting should be the same mass of atom being created at the left hand side. We have to remember the signs and also the symbols to represent the state or the physical state of each substance's reactant. So it's reacting. So in this case, we have known that the chemical equation cannot go alone, as it has to be together with the chemical reaction. So with this, we have come to the end of this lesson. So thank you very much for listening.